Do you ever wonder about cosmic giants? Let's get familiar with one. I'm talking about a black hole. What is it? How do they form? Why is there no light? Let's clear up some of the mysteries surrounding black holes. After a short intro, in a world full of noise, some truths stay cloaked. I am the voice from the shadows, unseen but heard. Science to history, we dive where others don't. Welcome to Cloaked Files. Subscribe. Stay curious. Stay hidden. What you are watching is a red giant star 25 times the mass of our sun, ready to die. It's called N6946BH1, soon to be a black hole. And what's that? Oh, a supernova. And we got our hero. A black hole is a region in space where gravity becomes so intense that even light can't escape. They're formed when a huge amount of matter is squeezed into a very small area. For example, a marble-sized black hole, roughly 9 millimeters in diameter, could have the mass of our entire Earth, which is almost 6 billion trillion metric tons. And for your information, 1 metric ton equals 1,000 kilograms. The smallest black holes are known as stellar mass black holes, with a minimum mass of around 3.8 times that of our Sun. To put that into perspective, our Sun has 333,000 times the mass of Earth. Now you can begin to imagine how massive the larger black holes can get. The largest black hole discovered so far is TON 618, an ultramassive black hole with a mass around 66 billion times that of the Sun. No need to worry, though. It's about 18.2 billion light-years away from Earth. How do black holes actually form? Black holes were once stars. When a massive star reaches the end of its life, its core runs out of fuel and can no longer support itself against gravity. This imbalance causes the core to collapse in a fraction of a second, and the star implodes, moving at about a quarter of the speed of light, feeding even more mass into the core. That's how a stellar black hole is formed. As for supermassive black holes, their origin is still cloaked in the files of mystery. Why light can't escape? Light travels at 300,000 kilometers per second, fast enough to circle Earth 7.5 times in 1 second. And yet it's still not fast enough to escape the gravity of a black hole. We don't really know what the gravitational pull of a black hole is like past the event horizon. When we see a black hole, what we're actually seeing is the event horizon and the accretion disk surrounding it. The accretion disk is a swirling disk of gas and dust that forms as matter spirals inward toward the black hole. The event horizon is the boundary around a black hole, where gravity becomes so intense that even light can't escape. If anything crosses it, there's no turning back. It heads straight toward the singularity. The singularity is the point at the center of a black hole, where gravity is thought to be infinitely strong. Matter is crushed into an infinitely small space, and the laws of physics as we know them break down. In simpler terms, it's a point of no return where space, time, and matter collapse into a single, infinitely dense point. And while we know a lot about black holes, we don't yet know what lies inside a singularity. Are black holes eternal? No, black holes don't live forever. According to Stephen Hawking's theory, black holes can slowly evaporate over time. Hawking proposed that black holes emit subatomic particles due to quantum effects near the event horizon. This emission is called Hawking radiation. Over time, it causes the black hole to lose energy and mass, potentially leading to its evaporation. While controversial at first, this theory is now widely accepted in the scientific community. There are many theories about black holes, but not all of them hold up. One common myth is that black holes are wormholes. They're not. Black holes are regions of space with extreme gravitational pull. Wormholes, on the other hand, are theoretical shortcuts between two points in spacetime, predicted by Einstein's general theory of relativity. So far, there's no observational evidence that wormholes exist. So we came to a point where we know something and don't know a lot of things. And we wait for these cloaked questions to be answered. Is there a connection between black holes and dark matter? What is the black hole's singularity truly made of? How fast can a black hole actually spin? Does the singularity generate electric fields? And if yes, to what extent? So many mysteries still cloaked in the fabric of the universe. Some researchers even propose that our universe might have originated from a black hole in a larger parent universe. Is that possible? Maybe. But that's a topic for another discussion. So stay tuned, and make sure to subscribe to Cloaked Files so we can stay in touch.